Hi, my name is Sandeep Kumar. Today I'll be talking about our work SGXGauge, a benchmark suite for Intel SGX. Here is the outline of the talk. First, I will explain the background, then the problem statement, then our work, and finally the conclusion. Let's start with the background. Intel SGX allows an application to be executed securely on a remote untrusted system in a region called enclave. The data and the code remains in encrypted form on the disk and the DRAM, and is only decrypted when it is brought to the chip. For this purpose, a portion of DRAM is reserved for SGX use and is called EPC, Enclave Page Cache. The size of the EPC is limited to 128 MB and 256 MB in the current version of SGX. Now, let us discuss the problem statement. The performance of the application running in SGX depends on many factors. One of them is how many times the CPU transition from the secure mode to unsecure mode. This is called eCall and OCall. The second is how much secure memory it is using. In the current version, as the secure memory is limited to 128 MB, any attempt to use beyond more than 128 MB results in a significant performance degradation. The SGX allows an application to go beyond 128 memory by using a paging mechanism. Prior work in this area ignores the impact of EPC on the application performance. SGXGauge measures the performance impact of EPC by using many different EPC intensive workloads. Now let us discuss SGXGauge. Our benchmark suite contains many different kind of application such as CPU intensive, transition intensive, secure memory intensive, and multi-threaded applications. Here's a list of our benchmarks. These benchmarks have been used by the SGX community in many different scenarios. The source code is available on GitHub. As you can see, for an EPC intensive application, the performance overhead can be up to 11x when we cross the EPC boundary. However, for CPU intensive applications, the size of the EPC doesn't matter much. Furthermore, in some applications which uses more than EPC memory but are also CPU intensive, the performance degradation is not that much, as the cost of EPC reductions are hidden by the CPU time. Intel just announced a new version of XGX that can be scaled to terabytes. However, while doing so, they have removed some of the security properties. They've also changed the mechanism how a page is securely added to the EPC. We are still exploring this. However, our benchmark suite can be scaled to terabytes and will be suitable for this new version of SGX. To conclude, we present a benchmark suite for SGX, which evaluate all the components of SGX that affects the performance of an application. We also evaluate the settings in a library of operating systems. The details are in the paper. And SGX case is future secure for the new version of SGX. Thank you.